An arc fault circuit interrupter, or AFCI, is a circuit breaker designed to detect electrical arcing faults. These faults can be a major cause of electrical fires. In addition to arc fault protection, some AFCIs also incorporate ground fault circuit interrupter, or GFCI, protection. GFCIs are designed to detect ground faults, which is current leakage to ground. These ground faults pose a risk of electrical shock or electrocution to people. Regarding protection levels, standard GFCIs, specifically Class A GFCIs, are designed to trip at the current of 5 mA. AFCIs that include GFCI protection may have varying trip thresholds depending on the manufacturer. For example, Siemens AFCIs manufactured prior to July 2002 had a trip threshold between 7 and 12 mA. After July 2002, the design was changed, and these AFCIs have a trip threshold closer to 30 mA. It's important to note that other manufacturers may have different thresholds for their AFCIs with GFCI protection. When dealing with older homes that have an ungrounded BX cable, using AFCIs with GFCI protection can offer an added layer of safety against both electrical fires and electrical shocks. However, it's essential to be aware of the potential limitations, especially regarding personnel protection, due to the higher trip threshold of some AFCIs. For personnel protection, the higher trip threshold found in some AFCIs may not provide adequate protection against electrical shocks. Therefore, when the highest level of personnel protection is required, it's recommended to install separate Class A GFCIs. These devices will trip at the lower 5 mA threshold, providing a greater degree of safety. For fire protection, AFCIs with a lower trip threshold, such as the Siemens models made before July 2002, may offer enhanced protection against electrical fires. As a general recommendation, always consult the manufacturer's specifications for the specific AFCI model you are considering. This will allow you to determine the trip threshold and ensure that the device is suitable for your intended application. It's also worth noting that AFCIs with GFCI protection are typically more expensive than standard AFCIs or GFCIs. Furthermore, AFCIs require periodic testing to verify that they are functioning correctly. In conclusion, while AFCIs with GFCI protection can be a valuable addition to older electrical systems, it's crucial to understand their limitations, particularly in regard to personnel protection. When maximum personnel protection is needed, Class A GFCIs are the preferred choice. It's always advisable to conduct a thorough evaluation of the existing electrical system and seek guidance from a qualified electrician to determine the most appropriate course of action. When it comes to electrical safety, understanding the nuances of different protective devices is paramount. Both AFCIs and GFCIs play vital roles in safeguarding people and property from electrical hazards, but they address different types of risks and have distinct operating characteristics. Let's delve deeper into the technical aspects of these devices, their applications, and the considerations for their effective use. An AFCI, or arc fault circuit interrupter, is specifically designed to detect arc faults, which are unintentional electrical discharges that can occur in a circuit. These arcs can generate intense heat, potentially igniting nearby combustible materials and leading to electrical fires. Arc faults can arise from various causes, including damaged or deteriorated wiring, loose connections, and insulation breakdown. AFCIs utilize sophisticated electronic circuitry to distinguish between normal arcing, such as that produced by a switch closing or a motor operating, and dangerous arcing that indicates a fault condition. When a hazardous arc is detected, the AFCI quickly trips the circuit, interrupting the flow of electricity and preventing a fire. There are different types of AFCIs, each designed for specific applications. Branch/feeder AFCIs are typically installed in the electrical panel and provide protection for the entire branch circuit. Combination AFCIs offer both branch/feeder protection and protection against series arcs, which can occur within cords or appliances. Outlet branch circuit AFCIs are installed at the outlet and protect against arcs downstream from the outlet. The National Electrical Code, or NEC, mandates AFCI protection in various locations throughout a dwelling, including bedrooms, living rooms, dining rooms, and other areas. The specific requirements vary depending on the addition of the NEC and local amendments. A GFCI, a ground fault circuit interrupter, is designed to protect people from electrical shock hazards. It operates by monitoring the balance of current flowing through the hot and neutral conductors of a circuit. Under normal conditions, the current flowing through the hot conductor should be equal to the current flowing through the neutral conductor. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance. A GFCI detects this imbalance and quickly trips the circuit, interrupting the flow of electricity and preventing a potentially lethal shock. Class A GFCIs, which are the most common type, are designed to trip at a current of 5 mA. This level of sensitivity provides a high degree of protection against electrical shock. GFCIs are required by the NEC in locations where there is a high risk of contact with water, such as bathrooms, kitchens, laundry areas, and outdoor receptacles. GFCIs are also commonly used in construction sites and other industrial settings. While both AFCIs and GFCIs provide important safety functions, it's crucial to understand that they address different types of hazards. AFCIs protect against electrical fires caused by arc faults, while GFCIs protect against electrical shock caused by ground faults. Some devices combine both AFCI and GFCI protection in a single unit, offering comprehensive protection against both types of hazards. In older homes with ungrounded wiring, the absence of a grounding conductor can increase the risk of electrical shock. In these situations, using AFCIs with GFCI protection can provide an added layer of safety. However, it's important to be aware of the potential limitations, particularly regarding personnel protection. As previously mentioned, some AFCIs with GFCI protection have a higher trip threshold than Class A GFCIs. This means that they may not provide the same level of protection against electrical shock. Therefore, when maximum personnel protection is required, it's recommended to install separate Class A GFCIs. When selecting AFCIs and GFCIs, it's essential to consider the manufacturer's specifications and the intended application. Different manufacturers may have different trip thresholds, operating characteristics, and performance specifications. It's also important to ensure that the devices are properly installed and tested to verify that they are functioning correctly. Regular testing of AFCIs and GFCIs is crucial to ensure their continued effectiveness. AFCIs should be tested periodically using a test button on the device. GFCIs should be tested monthly using the test button. If AFCI or GFCI fails to trip when tested, it should be replaced immediately. In addition to selecting and installing the appropriate protective devices, it's also important to practice safe electrical habits. Avoid overloading circuits, use extension cords properly, and never tamper with electrical wiring or equipment. If you are not comfortable working with electricity, always consult a qualified electrician. In summary, AFCIs and GFCIs are essential safety devices that protect against electrical fires and electrical shock. Understanding the differences between these devices, their applications, and their limitations is crucial for ensuring electrical safety in homes and businesses. By selecting and installing the appropriate protective devices, practicing safe electrical habits, and consulting with qualified electricians when necessary, we can minimize the risk of electrical hazards and create a safer environment for everyone. Now let's elaborate on some practical considerations when dealing with older homes and the integration of AFCIs and GFCIs into their electrical systems. Older homes often present unique challenges due to outdated wiring practices, the presence of ungrounded circuits, and potential deterioration of insulation. Before undertaking any electrical work in an older home, it's essential to conduct a thorough inspection of the existing electrical system. This inspection should include a visual examination of the wiring, outlets, and electrical panel, as well as testing of the circuits to identify any potential problems. If the inspection reveals significant issues, such as damaged wiring, overloaded circuits, or the absence of grounding, it may be necessary to upgrade the electrical system to meet current safety standards. Upgrading the electrical system can be a significant expense, but it's a worthwhile investment in the safety and well-being of the occupants. When working with ungrounded circuits in older homes, it's important to understand the limitations of AFCIs and GFCIs. While these devices can provide some degree of protection, they are not a substitute for a properly grounded electrical system. In an ungrounded circuit, a ground fault may not be detected until a person comes into contact with the energized equipment, creating a shock hazard. Therefore, it's crucial to take extra precautions when working with ungrounded circuits. One option for improving safety in older homes with ungrounded circuits is to install a ground fault circuit interrupter receptacle with no equipment ground label. This type of receptacle provides GFCI protection without requiring a grounding conductor. However, it's important to note that this approach does not eliminate the risk of electrical shock entirely. Another option is to install a new circuit with a grounding conductor. This involves running a new cable from the electrical panel to the outlet location, including a grounding wire that is connected to a grounding electrode, such as a ground rod or a metal water pipe. This approach provides the highest level of safety, but it can be more expensive and time-consuming than installing a GFCI receptacle. When installing AFCIs and GFCIs in older homes, it's important to choose devices that are compatible with the existing wiring system. Some older homes may have aluminum wiring, which requires special connectors and devices that are rated for use with aluminum. It's also important to ensure that the devices are properly sized for the circuit. Using an undersized device can lead to overheating and failure, while using an oversized device may not provide adequate protection. In addition to the technical considerations, it's also important to communicate effectively with the homeowner about the risks and benefits of different electrical safety measures. The homeowner should be informed about the limitations of AFCIs and GFCIs, the importance of regular testing, and the need for a properly grounded electrical system. The homeowner should also be involved in the decision-making process so that they can make informed choices about the safety of their home and family. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you are not comfortable performing the work yourself. A qualified electrician can assess the existing electrical system, identify potential hazards, and recommend the most appropriate safety measures. By taking the necessary precautions and working with qualified professionals, you can ensure the safety and reliability of the electrical system in your home.